downside possibly, that can become a choke point. And this diagram here kind of looks at like more of like a Netflix scale application or environment. But even without that scaling issue, still have UX requirements that may mean that you delegate that off to some other part of your environment. The latency for that call to come back may affect your UX. You may still need to look at more optimal ways of bringing that decision point back closer to your enforcement point to make sure UX or scaling requirements. And so on that item, like I think I mentioned the three types of phlebotomy, but one of the biggest considerations is that distance, or probably better termed, the time to the decision. How long is the latency between where you want the enforcement point to be and where you've got the decision being made? So based upon what your requirements are for that, whether scaling or UX, choose places that are closer to the actual enforcement point, which has the lowest latency, or push it out further to some distributed as a service type of component. But each of those then has, again, pros and cons. Like everything in software, there's no one size fits all. You've got to think about clearly, well, when does it make sense to take that simplistic approach? I think for most people who start down this path, they've moved themselves onto JOTs for their tokens and distributed in OAuth. You've got claims inside those. You say, well, I'm just going to use the claims for my fine grain. I'll use the OAuth scopes for my coarse grain, and I'll use the token expiry mechanism to work out when the thing is valid or not, and I won't worry about the rest. And maybe that works. So maybe in your use case, you can just tweak with that lifespan of your token, whatever range you're comfortable with, so that the window of risk you feel you're exposed to is mitigated. So then happy days, simple, and you're often running with this use case. But what I do find though is that will get you a good percentage. You're going to come up against some use cases that don't quite fit that. But the thing to be thinking here is, okay, how do I balance? If you engineer some really cool, complicated solution, someone's going to maintain that track. So, it's great to deploy it and build it, but then make sure it can live long enough to deliver value. So when you're balancing that, you may also then look about, well, maybe I can just live with that latency. Maybe I will call back out to that centralization point. The latency is smallish and my UX is hindered, so I'll just put up with that. Or possibly you can think, well, maybe I'll balance it out. Going back to that e-commerce application, maybe for my product catalog browsing API calls, maybe my shopping cart ones, I don't care so much about the security of those. What's the risk really? Let them go through. When I get to my checkout payment details, at that point I want to call back to the centralized place, make sure I've got the token still valid, that I can proceed. So again, no one size fits all, and these are three examples of the thinking that we went through to get to the use case we built out. But I think you'll have to adapt that to whatever your scenario is. So then, okay, that's the when and where and do it. But what is it actually we're trying to share? What are those authorization rules? So if you understand what they are, you can work at how can I get around and manage them. So there's two main components to them there. You need to be able to define them and apply them, basics of it. And you need to consider also that these policies, often we find organizations have a set of central governance policies. So you must, for every application, it must do A, B, C. But then there'll be a set of other policies which are, well, for this domain or this part of your organization application, to do X, Y, Z. So you've got a combination of these. You may treat those policies differently. Think in your mind about what types of policies they have and what categories they fit into and how you'd best manage those. Then once you've worked out what the policies are and the categories, you need some mechanism to propagate them. Assuming you've come to that flow chart that says, yeah, I have got some use cases I do need to propagate somewhere. Maybe it's just for my session management. I need to check back to a server. I can't live with timeouts. Well, then you need to work out, how you're going to do that. What is the mechanism you're going to use to get that information out from a central place to a decentralized place? And then the last point there, which kind of talks about the previous point, really is, possibly look at using OPA as a way to do that. Having go around this show here, you talk to all the different vendors. Everyone's got their own policy language. Policy language means it's hard to get that information to another enforcement So OPA is a piece of work that allows open policy framework for defining a single language for these policies, and then using that to multiple enforcement points. So it's something that's actively evolving at the moment. So if you can incorporate that, that'd be great also. So now the next 3 slides are some of the examples. So you see the top right there, there's a link to a Git repo. This is where we put all the artifacts in. And there is obviously some component of this which is specific to the layer 7 API gateway, but there's obviously a bunch of thinking applied to whatever your controller or enforcement point is. The first one here, and this is kind of like I've been spending quite a bit of time in this space lately because the CAPE information there, I'm not sure if you've come across it, but there's a whole lot of work that was done by Google and Microsoft to put together a framework that allows you to do pub/sub rather than request-response dissemination of identity or session relevant information. So the nice thing about that is that you don't need to have this callback all the time. You can have the information pushed out your ingress controller. And so we created a cache in our ingress controller, and we subscribed to the right events. And they came out to us from. We didn't build out a whole broker. That the full protocol requires a broker, but implement the client and the server components. We did that, and then brought the information, cached it in the ingress controller, and then applied that when the traffic was coming through us. So I think that topic there, it has to be, if we're doing zero trust properly and continuous authentication, you need to have a pub/sub design there somehow. So keep your eye on that one. This is more traditional. So here we're talking around just having the ability to have some general control of your governance of the policies themselves, put them into a repo of some kind. That repo is a truth, and we created ourselves an operator that's monitoring that repo, and when the repo changes, the operator grabs a new policy, gives the policy to the new pod, redeploys the pods, and going with that new policy deployed. So again, that's a traditional model, but something I still think that quite well. And then the third example we hit up was a combination of the previous two. Like here again, going back to that OPA topic that I mentioned, I think OPA has a role to play, and we were trying to, how would we actually use that? It's cool and it sounds good, but how do we actually use it? So we created a scenario where we had that sort of global corporate-wide policy need to deploy. We had that defined OPA agents running locally, and the OPA agent serves that up. So the ingress controller talks to the OPA agent to get that global policy. And then we had the operator version from previous years using a more traditional and a localized version of a policy that's out of a repo, combining those two together and enforcing the ingress controller. And then we also thought, okay, well, sure, that's good. We've got some approaches, but what else could you possibly do? We've got, for legacy applications, it's limited because you need to have something that's external. But if I'm building something that's new from scratch, microservice-based, designed to run in the cloud native, well, what could I possibly do there that would actually maybe do this in a better way or a more efficient way? And here we looked at how you could do some using event-based architecture to do just-in-time authorization. So the idea here is like the top part of the slide that talks around a typical sort of purchasing sort of system where you're checking for something and reserve inventory, ship the inventory. So that flow goes through, and there's a bunch of events that are triggering off the different microservices, parts of the flow. What if you could create a new, like a risk or an authorization service that is triggered off one of the same events that the normal flow is, and then it's doing the authorization checks based upon whatever context is available to it, then provided it completes the analysis or the inventory is checked out and the shipment happens, you can circumvent that process without having to have additional sort of ingress control or some other approach. So this allows you to build out that normal flow, but also then to scale that normal flow can scale as normal. Then you can have this additional just-in-time authorization added into that. So 20 minutes is very long. So we're coming up to about that. So just to summarize all that, I think centralizing it can help, and it's often where probably most people will start, but make sure you're thinking when you're starting beyond that, because there will be use cases that come your way. Everyone has them, If you don't think about them to start with, you're going to build yourself into a hole, and you'll be able to, it'll cost more to get out of down the track. Make sure you're thinking about multiple clouds, because multi-cloud is coming. Most of the large enterprises I talk to already have as a mandate, so that's coming. You need to be able to make sure that it can, whatever you do, it can be portable across those environments. Centralized design, that policy lifecycle management, you don't try and make that part of this solution. You'll let that be centralized and disseminate the information in some way, because there's no advantage in trying to change that. The over-engineering aspect, if anyone who's engineering here, great, and get excited, you want to go and make it really complicated and cool, but you've got to balance it out, because some poor bastard, you don't want to give them too much work. And then last but not least, look for opportunities. If you're building something new, you don't have to be constrained by some of the ways of doing things. Look for ways to use event-based architecture to be able to better. And with that, that's 20 minutes. So it's like speed dating for you guys. So hopefully you absorbed a bit of that and adds to whatever else you expected.
You are on time, Paul. Awesome, as usual. You nailed it. Guys, have any questions? We're happy to take it.
Well, I am around outside too, so
yeah, we have a Broadcom room, Broadcom booth also available there, and Paul will be there, so he's accessible anytime.